There's a concept called expectation. I'm going to be talking a lot about expected value, which is a type of expectation. So I'll set it up. It's an important concept. So what we have here is a spinner. Let me draw an arrow. So we have a twister, spinner, or something like that. It's a spinner, and we spin it around, and it lands over here. You win $500, and if it lands over here, you win $1,000. And the cost to spin the spinner is $550. And the question is, would you spin this wheel? Think about it for a second. Mark it on the side. We'll come back to that later. So the question is, would you spin this wheel or not? You could win 1,000 or for the cost $550. I'm going to show you this. This is actually the same thing as this. It's just shown in a different way. So here, it costs $550 to spin this wheel, but if you land there, you win 500, which really means you're losing $50. So then I've renamed. So this is still a spinner. I've renamed this side lose $50. We could pay $550 to win 1,000. That's the same thing as winning $450. And this one would be free. Well, sort of free, because if you land there, of course, you're losing money. So same idea. I mean, maybe this changes your mind if you look at it. So the question is, if you look at this wheel, would you spin this wheel? If it lands there, you lose $50. If it lands there, you win $450. I think I would spin it. But, you know, people may differ on their thoughts on that. Okay, this one over here. So what we have here now, we'll pretend that I've divided this up, so that's half, and that's a quarter, and that's a quarter, and this is another spinner. So if it spins around, it's going to land there. We win 1,000, 2,500, but the cost to play is $950. And the question is, again, would you spin that? So if you land here, you're losing more money, kind of breaking even, doing pretty well. I would pause the video and try to draw the alternative where the cost of the spin would be free. Assuming you've done that, it would look like this. So if the cost of spin was free, you're losing $450. You're losing $450, winning $50, winning $1,050. Would you spin this wheel? Okay. So, and the last one we're going to look at, I should probably save these somewhere, I need to come back to them. And the last kind of wheel to consider is number 3. So that one, if it lands in any of this area, we win $50. If it lands here, we win $1,500. Much sweeter. But this wheel costs $700 to spin, which means in our alternative free version of it, so whoops, I forgot to mark it down, but if the cost to spin was free, if we land here, we lose $200, and if we land here, we would win $800. So would you spin this wheel? And that's where we're going to try to get an idea. And a lot of these questions I'm asking you are mostly kind of like, when you first think of the question, you think of, well, would I personally spin this wheel? We're going to look at this mathematically. We're going to say, mathematically, should we spin these wheels or should we not spin these wheels? Let's take a look at this first wheel. So what we're going to say is, so if we win $1,000 half the time and $500 half the time, on average, we're going to get $750. And the cost to spin is $550. Now, we're never going to actually get $750, but on average, we're going to get $750. And since the average value of the wheel is more than the cost to spin, then spinning is actually a good idea here. So what we'll say is we say that the expected value for this wheel, all right, the expected, I totally screwed the spelling, the expected expected value of this wheel is going to be $750. It's never going to be $750, but we expect that it's going to be $750, which is more than $550, so worth spinning. Okay. If we look at the alternate version of the same wheel, so we could win 50, or we could win 450 or lose 50. On average, the average of 450 and negative 50 is 200. So in this case, the average value, and it's a little harder to see with this version of the wheel, which is kind of why I did this one second. But we're going to say that the expected value of this wheel is $200. And the cost to spin is free. Should you spin it? The answer is unambiguously yes. Yes, you should. And which makes sense. Notice here, the cost was $550. We expect to get $750, so we expect to get $200 more than we spent. The expected value is $200. They're the same wheel. Now over here, what's the average going to be on this side over here? A little harder to see. One way to think of it is that the average of 1,000 to 2,000 is 1,500. So this half of the wheel averages 1,500. This half of the wheel averages 500. And the average between 500 and 1,500 is going to be 1,000. So on average, when we spin this wheel, we're going to get $1,000. So we could say the expected value. The expected value. And I'm going to use, actually, I'm going to introduce a symbol for it. We're going to say that E of x is going to be the expected value of x, where I'm going to define x as dollars, the dollars that you get. So the expected value of this wheel is $1,000. It costs $950 for an expectation of 1,000. Should you spin it? Yes, you should. If we go to alternative world, over here, which was, remember, the same wheel as we had before, through the same kind of reasoning, the average of these two is going to be 550. So we could lose 450 or gain 550. And the average of negative 450 and 550 is just going to be $50. So the expectation for this wheel is $50. So should you spin it? I mean, yes, it's free. You expect to gain $50. You should spin it. Looking at this one over here. Okay. Now this one's a little less obvious. And so what we're going to do is actually we're going to go back to the other ones. And we're going to figure out the same things, but we're going to use a formula. We're going to have a formula to actually calculate the expectation before we do this one.